Okay, and now for question 9. After a costume change a week later. Okay, so we have this Norman window, a rectangle topped by a semicircle. We have the picture, you should have the picture in front of you, but I'm going to draw it again here for myself. So it says that the height of this thing is y. It says that I'm surprised it doesn't say this is 2x, or I'm surprised it doesn't say this is x. Actually what it does is it says that the radius of the circle on top is x. So this distance is x and this distance is y. So this is what we're dealing with. The question is, write p, which is the perimeter in terms of x and y and pi. So that shouldn't be too much of an issue. We have y plus 2x plus y, which is 2x plus 2y, and then this. Now, I think it's one thing that, I mean, come on, I mean, the circumference of a circle is 2 pi r, and so the circumference of a semicircle, which I might write as c half, will be pi r, and here, of course, the radius is x, so this will be pi x. Now, one thing, okay. So what I would like to do, you know, we have like f of x, you can write f of x and y. I'll do it here, why not? So we have the perimeter in terms of x and y is y plus y is 2y. X plus x is 2x. And then this little bit of the circumference of the semicircular bit is pi x. Now, if I want, I could take out x as a common factor here. And in fact, you could take, well, we won't take out 2. So you get 2y plus x times 2 plus pi. Okay, so that's what we're looking at. And that's part AI. So the big thing all the time, have we answered the question that's asked? Does it make sense? Have we answered the question that's asked? Have we written p in terms of x, y, and pi? We have. Okay, that's part B. So part 2 says, in a particular Norman window, the perimeter is equal to 12. So this thing is equal to 12. And it's just asking us to show that it's just asking us to solve for y, basically. This is not a difficult problem. So we're hoping to show that the perimeter, which is this, is equal to 12. Now there's a reference for x being between 0 and 12 divided by 2 plus pi. I think what that's about is, obviously x has to be positive, because x can't be negative. It could in theory be 0. Or could it? Could x be 0? In my opinion it couldn't. You wouldn't have a Norman window, you'd have an infinitely, I don't think that makes sense. I don't think that less than or equal to, or greater than or equal to 0, I think it should just be greater than. And similar story, I do think that y could be 0. So that in that one you just have the semicircle, that should be possible. But it's saying that, okay, so, I mean, what's the maximum value of x would be if this bit is as small as possible, so it would be y is equal to 0. And so the maximum possible x is divide both sides here by 2 plus pi, and you get that the maximum value of x is 12 divided by 2 plus pi. So those things. This isn't difficult. I mean, this is just solve for x. I have this plus x times 2 plus pi. The inverse of adding that is subtracting it. So I'm going to apply the function take away x times 2 plus pi. Apply that function to both sides. I get 2y is equal to 12 minus x times 2 plus pi. And then I have a multiplied by 2, and the inverse of multiplying by 2 is dividing by 2. So I'm going to apply that function to both sides. Divide both sides by 2. It will get rid of the multiplied by 2, and I get y is equal to 12 minus x times 2 plus pi, all divided by 2, which is what the question was looking for. So have we showed that y is equal to this for x in this region? We don't really have to worry about the region, it's fine. Yeah, we have. Yeah, so that's great. We've answered the question that's asked. part B. Okay, oh dear. So what this is saying, it's basically the kind of thing I was talking about, and really, like, could x be 0? Let's see. So B, algebraically it could be 0. I mean, abstractly it could. So we've got a little table here that's saying, okay, you got it in front of you. If x is its minimum value, what's the maximum value of y? This actually could end up being a very good question. So if x is 0, what's the maximum value of y? And if x is 12 over 2 plus pi, well, so I think we've kind of, okay, so one thing you could do is you could substitute x equals 0 into this, and you get y is equal to 12 over 2 is 6. So what you'd be getting there is, it wouldn't really be a rectangle. It's not a rectangle. It'd be like two pieces of wire of length 6 beside each other and just kind of bend it at the bottom. Look, we'll see what the question does. And this one, of course, I think actually does make sense, is where you do have an area. Basically y is equal to 0 here. If you substitute this into this, you end up with 12 minus 12 on top. So you get y is equal to 0. So this is, okay, we'll see where the question goes. On the diagram below, draw the graph of the linear function. Okay, now this is one where, okay, so we can, so there's different things we could do here. So we're asked to actually graph this thing between 0 and 12 over 2 pi. I would say that there's probably two approaches to this. The first would be to write this in the form y equal to mx plus c. And if you do that, it's easy to sketch because the c is where it cuts the y-axis and the m is the slope. And if it was a rough sketch, that would be the way to do it. But they have got some y coordinates there, so we want to be a bit more precise. I wouldn't be a fan of substituting in 0, 1, 2, whatever. I think you've got to use a bit more theory. And the theory here is that if you multiply this out, or not multiply it out, but write it in the form mx plus c, you end up with minus 2 plus pi over 2x plus 6. Now it does actually say it in the thing that it's a linear function. Well, I won't go into it. Strictly speaking, it's an affine function, but its graph is a line. And if it's a line, because it's of the form y equal to mx plus c, all you have to do is actually plot 2 points. And I think that's how I would approach this question. Because it's a line, you can just plot 2 points. Now, probably, and here are the 2 points. If we're going to sketch it, that says draw the graph. In my opinion, we can't do this exactly. We can only sketch it, do it roughly. But in any case, we want to look at what is 12 divided by 2 plus pi approximately equal to. And looking at this thing, we're only be able to reasonably go to maybe one decimal place. We'll see what we get. 12 divided by 2 plus pi, I get 2.3. Okay, roughly. So it's going to be x equals 0. Okay, let's do it. So there's lots of scales there. I don't really think you need all of that stuff. I'll just go as simple as this: x, y, and okay, at x equals 0, y is equal to 6. X equals to 0, y equals to 6, and then x approximately 2.3. So you can have your 2.5, but you're not going to be going that far. So we'll call this, well, we won't call it 2.3, we'll call it 12 over 2 plus pi. At that point, the y coordinate is 0. And it is a straight line because it tells us it's a linear, well, here it's definitely a line mx plus c. And we go down like this. Now, personally, if you go on and do a bit more maths, I do have an issue with x being 0. So what you might see if you were to go on and do a bit more maths at third level, we would do the following. So we would just draw a circle that isn't filled in, and this signifies that when x equals 0, that's not a point in the curve. And this one, you would fill it in, same as it is. We'll see if this becomes an issue in this question or not. Okay, Find the slope of the graph of y correct to 2 decimal places. Well, this is the slope. Now, interpret the slope in the context. We'll do that in a second. So, well, the multiple of x is always the slope. So, I was looking for 2 decimal places. So this is question 3. So the slope is equal to minus 2 plus pi over 12, which is approximately, and you could write equals to 2 decimal places. You shouldn't really write equals 2.3. This is not equals 2.3. You could say equals 2.3 to 1 decimal place, or what in my opinion should be done is what's called significant figures. This is called 2 significant figures, but anyway, that's another day. So I get 2 plus pi divided by 12. It's going to be 1 over this. Well, minus 1 over that. And we get 2 decimal places minus 0.43. Now, it's looking for this, says interpret the slope. I'm not actually sure what they want here. So I have 2 things that come to mind. I have 3 things that come to mind, and I presume I could look at the marking scheme and see which ones come up. I'm probably going to do that. I'm going to write 3 answers, and we'll see how they match the marking scheme, and I'll tell you which one I like the most. So probably the best one, the very simplest one. So you have quantitative is kind of stuff precise with numbers, qualitative is rough, and the slope is very good qualitatively. It's negative, and that means that when x gets bigger, y gets smaller. So the first thing I would say is that as x gets big, let's just write as x increases, y decreases. That's fair enough. Yeah, that's fair enough. Now the slope then is a bit more specific. It's rise over run. So what I'm saying is that as if x increases by 1, y decreases by approximately 0.43. This would be the second thing. If x increases by, because slope is the rate of change, you could even say if x increases by delta x, y, or if x changes by delta x, I'll throw that up here as well. If x, increases by 1, y decreases by approximately minus 0.43, or we could say if x changes by delta x, y changes by minus 0.43 delta x, It's because it's the rate of change. Have I got anything else? I don't think I do. I think that's enough. So we'll see. This is the one I really like. I mean, this is absolute full marks. So we're going to have a look at the marking scheme and see, did they come up with anything else? Did they give much for this? I'm not actually sure. I presume this is a question that comes up a lot, but I'm quite removed from the Leaving Cert at this stage. Well, the good news is this was kind of what they were looking for. If x increases by 1, y decreases by this much. The other issue I found is that I'm an idiot. I somehow mistransposed this from here to here. There's no 12 there, that's a 2. And therefore that this is divided by a factor of 6 too much. So this should be, my apologies, minus 2.57. So same story, minus 2.57. They didn't have this. This is a fuller answer than this. So this is kind of rough. This is a little bit better. This is what they're looking for. I think this is actually best. Okay, that's the question done. Right, we've got a different Norman window. And I think what we're looking for is finding the area. Okay, so I'll go from here. Okay, so we have the same shape again, so to find the area. So again, we're going to go for area in terms of x and y, and funny enough they give us the answer, which I don't know about that. Okay, so we have the y in terms of x, whatever. So let's see, the area of the Norman window in terms of x and y first. Suppose we've got the bottom, it was a rectangle. It had a base of 2x and a height of y, so that has an area of 2xy. And then the circle, it's a semicircle, so its area is half, pi r squared. And the radius here is x squared. Okay. Now, what we're asked to do is write this just in terms of x, which is a perfectly good question. So we should put the y back in terms of x, and well, we did this previously, so we get 2x and y is equal to 12 minus 2 plus pi times x. All divided by 2 plus a half pi x squared. Now, what's good here is they actually give us the answer. Well, they give us the answer for what the area is. Just in this is now just in terms of x, but we have to simplify this to make it look like the other thing. So one of the things, if you're looking at the answer there, it's divided by 2. So you want to keep this divided by 2. So I think what we're going to do is, let's see, we get maybe take out a common factor of a half is probably an idea. And if I take out a common factor of a half, I end up with 2x times 12 minus 2 plus pi x plus pi x squared. And I'm just going to, the answer is basically a multiple of x minus a multiple of x squared. So you have to be a bit careful here, you need to multiply this out. You've got 2x by 12, and what you can do here is you've got 2x by minus 2 plus pi times x. That's like if you've got, say, 6 by 7 by 5. The order of multiplication doesn't matter. If you want, you can do the 6 by the 5 first and get 30, and then multiply by the 7, which is a little bit easier, rather than doing 42 by 5, which isn't actually harder. But anyway, that's not the point. The point is you can do, instead of, if you want to do 2x by 2 plus pi by x, you can do 2x by x instead. So let's keep the half there a moment. Let's see what we get. 2x by 12 is 24x. And as I just said, now plus by minus is minus. 2x by x is 2x squared times 2 plus pi x squared. And now this bit is okay, this isn't quite there. So what do we want to do here now is probably, looks a little bit dodgy to be honest. I think maybe multiply this out actually. And we might get into a bit of difficulty, but we'll see what happens. So I get minus 4x squared. I see minus 2 pi x squared. And plus pi x squared. And what I'm going to do is I'm going to take out minus x squared out of this. And remember, multiplying by a half is dividing by 2. And if I take out the minus x squared, how many have I got? Well, I've got 4 here. And then I've, okay, now this is minus pi x squared. So if I take out minus x squared out of minus pi x squared, I'll have plus pi, which is what basically what we're looking for. Okay, now what it's looking for me to do is differentiate this thing. This actually isn't a bad question because so this is part 2. It's about how you manipulate this thing. So you might be trained, oh, I've got a fraction, I have to use the quotient rule. But there's no need to use the quotient rule here because it's not a function of x divided by a function of x. If you use your algebra, there's really no need. So using your algebra, so this is now the area as a function of x. Now, if you've got a sum, like say if 3 of your friends find 60 euros, and you want to share it out, say you find 320 euros or whatever, you can think of splitting the 320 euros. What I'm trying to say in a kind of an awkward way is if you're dividing a sum, everything gets divided. So 24x gets divided by 2 gives you 12x. And what I'm going to do here is, just like this, if you've got, say, two numbers multiplied together divided by another one, you can just divide one of them if you want. Like if you do 10 by 6 divided by 2, you don't have to divide both of them by 2. You either divide 10 by 2 or you divide 6 by 2. You get the same answer either way. So we'll do the same here. I'm going to fix the minus 4 plus pi. And I'm going to divide that by 2. And I'm going to set the x squared. And this is actually just a multiple of x minus a multiple of x squared. And this is easy to differentiate because because it's a sum, you can do it term by term. And differentiation is actually linear, which means that you can fix constants. So you can fix the 12. What is the derivative of x with respect to x? It's 1. You can fix the minus 4 plus pi over 2. And then differentiate x squared, the derivative of x squared is 2x. And then you can say maybe 2x divided by 2 is equal to 1. 12 by 1 is 12, so I get 12 minus 4 plus pi times 2. Excuse me, times x. Okay. And the question then becomes find